Welcome to the DIY Honda Garage channel. The trouble code P0979 indicates a short in the shift solenoid valve C circuit of the Honda Odyssey models from 2011 to 2017. This issue leads to a failure in the transmission's ability to shift into the second or fifth gears due to the fail-safe mechanism activated by the powertrain control module, PCM. The shift solenoid valves are electrical components that manage the flow of transmission fluid, thus controlling gear shifts. Located within the transmission assembly, solenoid valve C is specifically responsible for engaging or disengaging certain gears based on signals from the PCM. It is essential to differentiate this electrical issue from mechanical problems in the transmission, since P0979 is strictly a circuit problem. Initially, all freeze data and snapshots should be recorded using the Honda Diagnostic System, HDS, before any troubleshooting begins. DTC P0979 signifies a short in the electrical circuit of the shift solenoid valve C. This code specifically points to issues with the solenoid circuit rather than mechanical dysfunctions in the transmission itself. The affected component is the shift solenoid valve C, which plays a crucial role in managing gear shifts by regulating hydraulic pressure in the transmission. This solenoid is usually found within the transmission assembly, often nestled amongst other solenoids and valves that facilitate different gear engagements. Its electrical functionality allows the PCM to control when to shift gears, and any disruption in its circuit will prevent the vehicle from shifting into second or fifth gears, activating the fail-safe mode. It's important to clarify that during initial diagnostics, all relevant data from the vehicle systems should be documented to avoid oversight during troubleshooting. The possible causes for the DTC P0979 primarily involve electrical circuit issues rather than mechanical problems. A significant potential cause is a blown number B5 7.5 amp fuse located in the underhood fuse relay box, which protects circuit integrity. Another potential issue could be an open circuit in the wiring that connects the shift solenoid valve C to the PCM, disrupting the signals necessary for shifting. Moreover, loose or corroded connectors between these components can lead to intermittent connectivity, causing the fail-safe mode to activate. These electrical concerns are critical to examine, as they directly impact the solenoid's operational capabilities and the transmission's performance. Thoroughly checking each potential cause will aid in determining the root of the problem. The primary symptom associated with DTC P0979 is that the transmission fails to shift into the second or fifth gears. This occurs because the fail-safe mechanism, triggered by the PCM, prevents the vehicle from operating in these gears until the issue is resolved. As a result, the vehicle may feel sluggish or perform poorly due to being limited to other gear ratios. Drivers may also notice indicators or warning lights on the dashboard signaling a transmission issue. The inability to shift gears can significantly impact drivability, leading to a frustrating experience. Observing these symptoms indicates that the vehicle requires immediate attention to avoid further complications. The first troubleshooting step for addressing DTC P0979 begins by turning the ignition switch to the on position, I, without starting the engine. It is crucial to utilize the Honda Diagnostic System, HDS, for this procedure. After setting the ignition, the next action involves clearing the Diagnostic Trouble Code, DTC, using the HDS tool. Once cleared, start the engine while the gear is in park, P, and wait for at least 1 second. Following this, it is essential to check for any pending or confirmed DTCs using the HDS functionality. If the DTC P0979 still appears, it indicates that further investigation into the electrical circuit is necessary. However, if it does not reappear, It may suggest an intermittent failure and indicates that the system appears to be functional at that moment. After evaluating for the presence of DTC P0979 in the previous step, turn the ignition switch to the lock position, 0. This is a safety measure that ensures no electrical systems are engaged while conducting further diagnostics. The next step is to examine the number B5 7.5A fuse located in the underhood fuse/relay box. This fuse is crucial for protecting the circuit associated with the shift solenoid valve C. Confirming the integrity of the fuse is essential. If it is blown, it indicates a potential short circuit to body ground in the wiring. On the other hand, if the fuse is intact, it implies that the circuit may still have issues requiring further diagnostic steps, leading you to investigate other potential electrical problems within the wiring or connectors. In this troubleshooting step, the task begins by jumping the SCS, Service Check System, line using the HDS. This step allows the technician to bypass certain systems for diagnostic purposes. After that, proceed to disconnect the connector A from the Powertrain Control Module, PCM, ensuring that all safety protocols are observed to avoid damaging the unit. Once disconnected, turn the ignition switch back to the on position, II, to power the vehicle's electrical systems. The next action is to measure the voltage between the A1 terminal of the PCM connector and a reliable body ground. It is essential to check if there is battery voltage present at this terminal, as this voltage is necessary for the solenoid valve to function properly. If no voltage is detected, it indicates an open in the wire, necessitating further inspection of the wiring from the PCM to the underhood fuse relay box. After measuring and verifying the voltage status at the PCM connector A, the next step involves turning the ignition switch back to the lock position, 0, to ensure all systems are powered down for safety. Following this, disconnect the connector for shift solenoid valve C to entirely isolate it from the circuit. This disconnection facilitates the assessment of the solenoid itself and its related wiring. At this stage, any identified issues within the wiring harness or solenoid connectors need to be addressed and repaired. Ensuring that the wiring is intact and properly connected is vital before moving forward. Once repairs are completed, testing the functionality of the transmission's shifting mechanism is essential to confirm that the issue has been resolved and that DTC P0979 no longer appears. To validate the repairs made concerning DTC P0979, the technician must undertake a final verification step. This involves using the Honda Diagnostic System, HDS, to check for any remaining or new DTCs following the repairs. It is crucial to confirm that the transmission shifts correctly through all gears, particularly the second and fifth, which were affected by the initial issue. Additionally, assessing the overall performance of the vehicle is necessary to ensure that it operates smoothly without any abnormal behavior or symptoms. Documenting the findings from this verification step is essential, as it provides a comprehensive account of the service performed and can be invaluable for future diagnostic efforts. While the focus has been on troubleshooting and repairing DTC P0979, implementing preventive maintenance is essential to avoid future occurrences. Regular electrical inspections are vital, as they allow for early detection of any wiring or connection issues that could lead to similar trouble codes. It is also crucial to regularly check the integrity of the wiring connected to the shift solenoid and the PCM, ensuring that there are no signs of wear or damage. Monitoring the quality and level of transmission fluid is equally important, as low or contaminated fluid can affect the overall functioning of the transmission. Conducting periodic diagnostics with the HDS can help catch potential issues before they escalate into more significant faults. Lastly, keeping all electrical connectors clean and corrosion-free will contribute to a reliable electrical system, minimizing the risk of electrical faults in the future. In conclusion, DTC P0979 signals an electrical issue specifically related to the circuit of the shift solenoid valve C in the Honda Odyssey models from 2011 to 2017. Understanding that this is not a result of mechanical failures is essential for effective troubleshooting. The steps outlined for diagnosis emphasize the importance of checking electrical components, including fuses, connections, and wiring integrity to pinpoint the fault accurately. Preventive measures can further safeguard against similar issues arising in the future, ensuring the transmission operates smoothly at all times. Ultimately, the goal is to maintain optimal vehicle performance and provide a reliable driving experience for the owners of these vehicles. Please like and subscribe to the channel. See you next time!